Hello everybody, welcome to video number 2 for Algebra 2. Now, today we get to talk about problem solving, and more specifically, word problems. Now, I want to take you a little bit into my world. When I say, okay everybody, we're going to do word problems today, from about 80% of the class, I see this face. Worried, nervous, scared. And from the other 20%, I see this boy. Just sheer panic. Okay? I'm hoping that by the end of this class we can get you over this. Hopefully word problems don't scare you. Now, they may make you a little nervous because you don't know exactly how to attack them. That's why they're difficult, because there isn't a set exact way of how to do it. But isn't that how problems are going to be in real life? There's not a real specific way as to how to attack every problem. That's why people get paid to solve problems. If it was easy, everybody'd be doing it, and we wouldn't need to pay somebody to figure things out. Okay? So problem solving, it's a great skill to have. Now, and math is great for problem solving skills because we have all sorts of different types of problems to solve. So in this video, we're going to kind of go slow, but I've got 4 word problems that I want to solve. Okay? All right, I'm just going to take you through it step by step the way I would solve it. Now, let's talk about this. You'll hear me say this a lot. It is okay. There is nothing wrong in this class with not doing the problem the quickest way possible. Sometimes you have to go through Haver to get to Bozeman. As long as you end up in Bozeman, you're in good shape. Okay? You might take the long way around. You might take a few avenues that take you in the completely wrong direction. But as long as you end up where you need to be, it's okay. All right? The greatest problems weren't always solved on the first try. Just ask the boy who invented the light bulb. Okay, here we go. Let's tackle the first one. The Acela train travels between Boston and Washington. Boston and Washington. I believe that's D.C. It's got to be. A distance of 457 miles. The trip takes 6.5 hours. What is the average speed? Well, from the last little section, we know that distance equals rate times time, correct? Miles per hour, feet per second, rate, and time. Okay? If we look at it that way, if I divide everything by t, I get rate equals distance divided by time. Distance, miles per hour, time, okay? Distance equals rate times time, rate equals distance divided by time. Just a little algebra thing, okay? Well, let's just use this formula and fill in what we know. If I know that distance equals rate times time, let's fill in what we know. I've got a distance of 457 miles. That equals the rate. That's what I want to know. The rate is the speed. How fast am I going? Times the time, which is 6.5 hours. Well, let's divide by 6.5. Let's just do some algebra. 6.5. And I believe the rate is, where am I at here? 70.3 miles per hour. 70.3 miles per hour. It's a fairly speedy train. That's faster than any car you could get going over there on the East Coast. Too many people over there, man. Too many people. Okay, here we go. Next problem. A paramotor. A paramotor is a parachute propelled by a fan-like motor. Okay, so you've got a parachute up in the sky, this fan behind it, and he's flying around, buzzing around. The table shows the height h of the paramotorist t minutes after beginning a descent. Descent means coming down to the ground. Find the height of the paramotorist after 7 minutes. Well, here's our little problem, folks. It's given me so many minutes, but it doesn't give me 7 minutes, so I can't just look at the table and figure it out. Now, so I need to write an equation. Here is where people make mistakes. Okay? They want to say that t equals h minus 250. Why do they, I screwed up my h and my t. They usually get the t right. The height equals t minus 250. Now, why do they say that? Well, they've noticed that this thing goes down by 250 every time. So most people think that I'm going to have to just subtract 250 every time. Not the case. Not the case. I know that's your intuition, but that's not how it's going to work. Okay? Think about this. If I plug this in, after 0 minutes, if I plug in 0 minus 250, I'm negative 250. I'm negative 250. Something has gone wrong. Now, if I plug in 1 minus 250, I'm at 249. I'm actually gaining ground. Okay? Something is wrong. Something is wrong here. Okay? Well, let's take a look at what we know. We know that equation is wrong. But we do know that that thing is going down. You're dropping at 250 feet per minute. There's got to be something to that. Okay? I want to know the height after t minutes. So I'm going to go h equals. Now, every single minute, how far am I dropping? I'm dropping 250 feet. So I'm going to take t times 250. Now the problem is, where did I start? I started 2,000 feet above the ground. So if I take this equation, h equals 2,000, and every minute I'm dropping 250 feet, will that give me the answer I'm looking for? Well, let's plug in numbers. If I plug in 1, I should end up with 1,750. 2,000 minus 1 times 250. It's going to work out, isn't it? 1,750. Let's plug in 4 and see if we get 1,000. 2,000 minus 4 times 250. Okay? That's 2,000 minus 1,000. Hey, it's going to work. 1,000. Okay? So again, how did I get this equation? I knew I dropped by 250 every minute, so I had to take 250 times minutes, times my time. And then since I was descending, I needed a starting point, which was 2,000, and from there, I dropped. So that's why it was 2,000 minus. Now it wants to know how far after 7 minutes. Well, let's use our equation. H equals 2,000 minus 7 times 250. Okay? H equals 2,000 minus 7 times 250 is 1,750. So H equals 250 feet. Okay? And if you've noticed the pattern, it's going to take us 1 more minute to get down to the ground, to get down to 0. Okay? Again, kind of, it may not be intuitive how that worked, okay, but it makes sense. Hopefully it makes sense when you see it. I've got to take 250 times every minute. Okay, next one. You're hanging 4 championship banners on a wall in your school's gym. That's a good problem to have. That means we're winning some championships. I hope we have that problem this year. The banners are 8 feet wide. The wall is 62 feet long. There should be an equal amount of space between the ends of the wall and the banners, and between each pair of banners. How far apart should the banners be placed? Well, I've got myself a wall, and I've got 4 banners on the wall. And they're saying that This space needs to be the same as this space, and this space. Well, if they're all the same, but I don't know how long each are. I know that the whole thing here, I know the whole thing here is 62 feet. And I know each banner is 8 feet. But I don't know how big each one of these little spaces is. But I know they're all the same, right? So can I call each one of them X? As long as X represents the same number the whole time. Now can I just make a big long equation just based on the wall? I've got X plus 8 plus X plus 8 plus X plus 8. You getting the pattern here? Plus X plus 8 plus X equals 62 feet, right? Because the whole thing is 62 feet long. Well, now let's get our like terms together. We got 1, 2, 3, 4, 5. 5x plus 4 eighths. 8 times 4 is 32 equals 62. Now we're just doing algebra. Algebra 1 stuff. Easy. 5x equals 30 divided by 5. X equals 6. Draw pictures, folks. Draw pictures. I even did it in Christmas colors for you. Make you feel happy about the problem. Draw pictures. They help. That problem is kind of a pain in the butt to read and try and figure out. You draw a picture, it makes sense. It's right there in front of you. Don't be afraid to draw pictures. There's no shame in drawing pictures. There is no shame in drawing pictures. I don't know where we picked that up, but I see all sorts of students try and look at that problem and try and figure it out from the words. Draw a picture. Make life easy on yourself. The car used 16 gallons of gasoline and traveled a total distance of 460 miles. The car's fuel efficiency is 30 miles per gallon on the highway and 25 miles per gallon in the city. How many gallons of gasoline were used on the highway? Okay, we care about highway, and I forgot a question mark there. We care about highway. Well, first thing I got to do is set up an equation. Let's pick some pieces out. 16 total gallons. Okay? 460, not 50, 460 miles. Gosh dang it. Okay? Car's fuel efficiency is 30 miles per gallon on the highway. So, I'm using H number of gallons, H gallons on highway. And the reason I'm using that one is because that's the one I care about at the end of the day. So I'm going to try and make life easier on myself. Okay? So if I'm using H gallons of gasoline on the highway, how many am I using in the city? How many am I using in the city? Well, think about this. If I used 8 of those gallons on the highway, that means I used 8 of them in the city, correct? How'd you do that? You subtracted from 16. If I used 4 on the highway, that means I used 12 in the city. So I'm going to use 16 minus however many gallons I use on the highway in the city. Okay? Now I'm going 25 miles per gallon. Okay, now my label is miles per gallon. So if I start going here, if I start looking at what I have, on the highway I'm getting 30 miles per gallon on the highway. And in the city, I'm getting 25 miles per gallon, and I'm using however many gallons I have left over, right? And when I'm done, I know I used 16 gallons, so I know I used some combination here. And when I'm done, I know I've traveled 460 miles. Now we just go through an algebra size. 30H plus 25 times 16 is 400. Minus 25. H equals 460. Gotta hurry here. 5H equals, 460 equals 60. H equals 30. Now, I'm going to stop the video. We can clean this up later because I am at 15 minutes.